Today's lesson is on zero and negative exponents. Here we have an example of lots of exponents they all have the base of 2, and we have positive ones and then their opposites, the negative. So let's evaluate these. We start with 2 to the first power is 2, 2 to the second power 4, and then it is doubling as you go up. So 2, 4, 8, 16, and 32. So as you go down, the numbers are being cut in half. So as you go down, cut 2 in half, it is 1. So 2 to the power of 0 is 1, and then we will continue cutting in half as you go up. So half of 1 is 1/2, and then half of 1/2 is 1/4, and then keep cutting in half, 1/8, 1/16, and 1/32. And then just notice as you look across, these match up. You have 2 and then 1/2. These match up, you have 4 and then 1/4. 8, 1/8, and that same thing continues as you go. So we're going to use that concept in today's lesson. In that last example, when we had 2 to the power of 0, it was equal to 1. And actually, any number, no matter what it is, to the power of 0 is always 1. So this is a rule you will definitely need to know. So some other examples, let's see, 5 to the power of 0 is 1. Even if you do a negative number, negative 2 to the power of 0 is 1. Or even if you do a fraction, 1/3, anything to the power of 0 is always 1. And then in that last example, when we had negative exponents, it meant that we were changing the numbers into fractions. The negative exponents did not mean that you were changing them to negative numbers. So the rule is, anytime you have a number and you raise it to the power of a negative exponent, you always do 1 over and then take the same number but to its positive version of that exponent. So for example, when we had 2 to the power of negative 3, it really is 1 over 2 to the power of positive 3, which is why we got 1/8. We're going to do a bunch of different examples in which we will evaluate expressions with negative exponents so you get the hang of it. So for the first one, I have 2 to the power of negative 6, but we're not going to evaluate it. The directions say just to rewrite this using a positive exponent. So to rewrite it, all we have to do, let's see, a negative exponent means fraction. It means 1 over 2 to its positive 6th power. So we're not going to evaluate what that finally equals. We're just rewriting it as a positive exponent. Now this example, I want you to think about going backwards. What if I have 1 over 49? I want to rewrite this fraction, but I want to rewrite it using a negative exponent. Well, I know that 49 is a perfect square, so I could rewrite it first as 1 over 49 is the same as 7 squared. And to keep thinking backwards, if you have 1 over this power, it's the same as if you had 7 to the power of negative 2. So going backwards, this case, writing it with a negative exponent. Okay, now we're going to do examples where we actually evaluate to get the final number. First, we have a negative base, negative 4, and then we have a negative 3 as the exponent. And think about the rule. When you have a negative number in parentheses, and you have an odd exponent, that means your final answer will be a negative number. But since we have this negative exponent, let's just rewrite it as 1 over, the base stays the same, so the base stays negative 4, and then you change it to a positive. And now you can continue evaluating. It's 1 over negative 4 to the power of 3 is negative, and then 4 to the third power is 64. But we never write our final answer with a negative number in the denominator. You can rewrite it as just a negative number out in front. So it's negative 1/64. Alright, second example, now we have negative 7 to the power of negative 4. And let's see, my base is negative, but my exponent is even. So that means my final answer will go to positive. But if we rewrite it, 1 over, keep the same base, negative 7. Change your exponent to a positive 4. And now evaluate 7 to the 4th power. 1 over 2,401. And remember, it's positive because of the even exponent. Alright, in this example we have a negative exponent and we're multiplying. But do order of operations, just like always. We're going to evaluate the exponent first. So 27 times, rewrite this as a fraction because we have a negative exponent, 1 over 3 to the power of a positive 3. And then continue with your exponent. This is 27 times 1 over 3 to the third power is 27. And now we just need to multiply. When you multiply a number by a fraction, you multiply to its numerator. So 27 times 1 is 27 over 27, which equals 1. In this example, we have a variable expression, and then we know that x equals negative 8, so we have to plug in negative 8 in for x. And the key thing is, when you're plugging in to a variable, you need to have it in parentheses, so negative 8 to the power of negative 2. So if I rewrite this as a fraction, it would be 1 over, keep the base the same as negative 8, but change the exponent to a positive 2, and continue. It's 1 over, this would make it positive because the exponent's even, 1 over 64. Here are 3 last examples. I want you to pause the video and write them down and see if you can figure them out, and then come back and check your answer. For the first one, anything to the power of 0 is 1, and then I'm going to rewrite this as a fraction, kept the same base, changed my exponent to positive, and now I have 1 over negative 2 to the power of 5, odd exponent, so my answer is negative, and 2 to the 5th power is 32, and I can rewrite that as a negative out in front. Negative 1 over 32. Here if you plug in 5 for x, you put in parentheses and that negative sign that was originally there stays out in front. So a negative, and then change it to a fraction, 1 over 5 to the power of positive 3, which is negative 1 over 125. And finally the last one, plug in 6 to the power of negative 3. Rewrite it as a fraction, 1 over 6 to the power of positive 3, which equals 1 over 216. So there are lots of different examples of how you can rewrite expressions when you have negative exponents. Good luck with the lesson!